Three-phase power we can calculate by equation. Normally these are for the balance load. Three-phase power is equal to root 3 ELIL into cos theta. So this equation. So this is an equation to calculate the three-phase power, but this one only is suitable for the balance load. Balance load you can use as usually line voltage multiply, line current multiply the power factor. But for the unbalanced load, you cannot use this formula. Unbalanced load. This formula cannot be used. So you can use a formula, three-phase power equal to root 3 E line I line into cos theta only for the balanced load. For the unbalanced load, we cannot use it. So that for the how to calculate the unbalanced load. So you see that this is a problem. So this is the three-phase connection. So this becomes as IAB here. So this becomes as ZCA, ZBC, and as ZAB. Okay, currents are flowing in. So this current is an IAB. The voltage we get a VAB. And here is current is a IBC, voltage is a VBC. The current is a ICA. The voltage becomes a VCA. So this is as a saturation. For A phase, AB, the current flow is a IAB, the voltage is a VAB. And for the BC component, the current is a IBC, the voltage is a VBC. And similarly, ACA, current ICA and the voltage VCA. So this is as a phase current are flowing. So this three-phase power you can calculate. Three-phase power for unbalanced. Three-phase power for unbalanced data load you can calculate. So the voltage is a VAB, IAB, cos theta between the VAB and the IAB, plus VBC, IBC, and the cos angle theta between the VBC and the IBC. Plus VCA into ICA. Cos angle theta between VCA and the ICA. So we can use this formula. This means that phase voltage multiply the phase current and the angle between the phase voltage and phase current. For the AB phase, BC phase, and CA phase, you find and the H. So by this way you have to calculate. So for the data connection load, the phase voltage and the line voltage are the same. The line voltage are given the 300 volt. So the VAB is 300 angle 0, VBC is 300 angle minus 120, VCA is 300 angle plus 120. So this is we got that angle. VAB 300 angle 0, VBC 300 angle minus 120, VCA 300 angle plus 120. So this is a three-phase. Data connection.
Are we basing this off that equation?
Yes, based on this one. Okay, the currents are we already calculated. The IAB is 20 angle 20, IBC is at 30 angle minus 145, ICA is at 12 angle 120 degree ampere. So we also calculate the current. In the previous problem, we have already calculated the current. So IAB is 20 angle 20. IBC. So IBC is 30 angle minus 145. And the ICA. ICA is 12 angle 120. So 12 angle 120. So we calculate the current. So then you can calculate the power. So we have to use the VAB, IAB, cos theta between VAB and IAB. So we see the first plot there's a VAB vector. So this is the VAB vector here. So 300 angle 0. And IAB is 20 angle 20. So this means that this is IAB. 20 angle 20. So this angle is 20. So that the angle between VAB and IAB is 20 degrees. So you can calculate VAB, IAB, cos angle theta between VAB and IAB. So this becomes the VAB is 300, IAB is 200, and the cos 20 degrees. So by solving this one, you got the power for the AB's phase. So this power for the AB component is the calculation. This is a 56381. And also you can calculate the power for BC. So this is for the AB. And also calculate for the BC. So BC phase, the voltage IBC is 300 angle minus 120. So this becomes a 300 angle minus 120. So this is a VBC. IBC is 30 angle minus 145. So this one is a IAC. IBC. So this is a minus 145. So 120 is here, 145 is this one. So this angle different. This angle different is 25 degrees. So this becomes the VBC, IBC, cos angle theta between the VBC and the IBC. So this is the VBC is, you got the 300. IBC is, you got the IBC here is the 30. So angle cos 25. So by solving this one, this is a 85. A156.81. So this is for the BC phase, and also you can calculate for the CA. So CA you also need to draw the BCA and ICA vector.
Why do you have 300 times 200? Shouldn't it be 20?
300 yes, plus 20. So another one is that we have to calculate the BCA. So CA phase we have to find the BCA. So this is a BCA. So this is 300 angle 120. And ICA also 12 angle 120. This is ICA. So in this case, this is an in phase. In phase means that cos angle theta is 0. So then we can calculate the VCA, ICA into theta. So between the VCA and ICA. Cos 0. So this is 36001. Then to the power, you can calculate. So to the power, you have to add all 3. 5638 plus A1 56.8 plus 3600. And you got the to the power is we got the 173951. You can calculate the total power. So in this case, this is the formula to calculate this three-phase data unbalance. For the balance, you can use the √3 EI cos theta. For the data unbalance, you cannot use this formula.